Okay, here we go. We're gonna, this might be a little rough because I haven't done it already, but we're gonna go through and try and run some tests. So the first thing that, that I would like for you guys to do is do a crosstab and chi-square test. So we are going to look at, let's see, what do we have here? Let's look at the religion distribution among our clinicians, just to see. So we're going to go to Analyze Descriptive Statistics, Crosstabs. So for our rows, we're going to put religion. For our columns, we're going to put clinician type. Then hit this little statistics box here and request that it run a chi-square test. Then hit continue. Then for our cells, we are going to want column percentages. Yes. Yeah, statistics.
What is it?
A chi-square, so she talked about it in class briefly. It's basically the test that you want to use for comparing two categorical variables. So when you have no mean to calculate, you're looking to see whether the distribution among the categories is systematic or not. So the null hypothesis is that the variables are independent, and the alternative is that they're not independent. And then press OK. Okay, so here we have our different religion types, which are not labeled, but there's 7 of them, and our different clinician types at the top. And then we can see that, so what you're comparing against each other would be the different rows against the total. So, so if you look at the total, say for religion type number 3, that has the biggest majority and is probably Christian, is that 52% of the total sample is a religion type number 3. And then if you look across at the clinician types, we see that number 1, they have 56% of their clients are religion type 3, 2 is half of them, and 3 is 53% of them. So those are all approximately similar. I wouldn't expect to get a significant result. And then we look at our chi-square test and our significance, and we see that these variables are independent. There doesn't seem to be a clustering of certain religions being assigned to particular types of clinicians. Yeah, so we know that because in our chi-square tests, the first row, Pearson chi-square, the last column, the two-sided significance is not below 0.05. Yeah, if it were anything below 0.05, then we would say that it is significant.
So this means we accept the null hypothesis.
Yep. So the other reason why I wanted to show you a crosstab is that a crosstab is a really great way to check when you're creating variables. So I think for the homework, one of the things that, that we did in class before was we recoded a variable into the social worker or not, right? So let's do that real quick. That was recode into different variables. Our input variable is clinician type, old and new values. Social workers were, does anybody remember? 1 or 2?
3.
Social workers were 3? Okay. That is under data, or no, actually, I think it's under transform. Transform, recode into different variables. And then our input variable is going to be the clinician type. Put old and new values. The old value was 1. The new value will be 0. And if the old value was 2, the new value will be 0 for not a social worker. And if it's 3 for a social worker, the new value will be 1 for a social worker. Continue. We need to name our variable SW for social worker. And the label will be social worker.
So wait, 3 was social?
Yeah.
So we're...
Yep. And we're going to hit OK. And then if we want to check and make sure that that recode went properly, we can go into Analyze, Descriptive Statistics, Crosstabs. But instead of looking at religion, we're going to look at, actually want to put our new social worker variable as the columns and the clinician type as the rows. We don't need to do a chi-square test on this because we're just checking our work. And we don't need to see any percentages. Just hit continue, okay. And there we see that it did it correctly. So for clinician types 1 and 2, they have a value of 0 for social worker, and clinician type 3 has a value of 1 for social worker.
Oh, so we're comparing old variables to new variables?
Yeah. Yep. Okay, so that is crosstabs and chi-square tests. Any questions on those before we move on to some t-tests? Okay. So the first thing that we want to do is a one samples t-test. So if we want to compare whether people who had a social worker for their clinician had the same mean general score as the rest of everybody else. So not comparing, like taking everybody as a whole and that mean and comparing it to those that were just the social workers. So the first thing we need to do is find out what the mean is. Or I believe that somewhere in your homework, there is a reference number that is provided to you that you could use if you have that information. So if you don't have that information and you want to look it up for this particular sample, what the mean is, you would go to Analyze, Compare Means, Means. And our dependent list is going to be treatment score pre, and our independent list is our categorical social worker dummy variable. We're going to hit OK. And then what we get is the means for the different groups. So we can see that the mean for people who didn't have a social worker was 31.4. The mean for social workers, clinicians, was 37.0. And then the mean for the overall mean is 33.1. So, but this doesn't tell us anything about whether those differences are significant or not. So we're going to do a one sample t-test. We're going to go to Analyze, Compare Means, one sample t-test. And we are going to test our same variable, treatment score pre, and we're going to test it against what we just calculated was the overall mean of 33.1. So we put that in our little test value there. So this is when you want to compare against a known, specified, for whatever reason, you have a value already that you want to compare against, say from larger data, from general norms in the field, or whatever it is. And you hit OK, but we forgot a step. We need to select cases first. So we're going to go to Data, Select Cases, and we're going to just look at the clients with social workers. So, so we go to Select Cases. If condition is satisfied, we hit that if, and then we put our social worker variable equals 1. And then we hit Continue. And we hit OK. And then we go back again to Analyze, Compare Means, one sample t-test. We already have everything. That's a nice thing about SPSS is it saves what you did the last time. If you ever are trying to do something new, you can just hit reset. But it's nice if you need the exact thing happened and we need to go back and do it again. You hit OK. And let's see. It is not a significant difference. So treatment score pre, our significance is 0.11.
What does it mean if your number has a Yeah, that's like to do this decision.
How many, when it says your N under your treatment score pre, how many? 17.
The top numbers are the same, but then the ones that has. Just.
And you use 33.1 as the test value?
Should say right there. I've got a little confused in class about how to interpret the 95% confidence interval and how that relates to what is the actual interval.
Yeah, so the interval is around this mean difference category. So it is we can be 95% confident that the true mean difference of the population is between -1 and 9.
So that's just the difference between, the true difference between the mean.
Yes, and your test value. Yes.
So it doesn't tell us what the actual.
Well, what it does tell us is that if we look at these values, it actually is entirely possible that instead of having a higher value, it could even actually be a lower value. We just don't know where in that. And that, because it overlaps 0, because the confidence interval overlaps 0, that's why we're getting a non-significant result. Because if it were definitely positive, then that would be our significance. But because it might be 1 point less, that's why we can't reject the null hypothesis. But that is not a very big overlap of just 1 point. And that's a pretty wide interval of 10 points. So that is part of the risk of trying to do analysis on such small samples. So we can't, because it's a small sample, we just don't know if there really was a systematic difference. But my inclination would be if we get a 0.11 significance, a p-value of 0.11, that is very close to a significant result. And if we had more data and were to, say, expand the program nationally, I think that we might end up with enough information that these could become a significant difference if something were not done to address how cases get assigned just to clinicians. So given this sample that we have, we can't be confident that there's a difference. But if we had more information, we might want to run those tests again. Yeah. Okay, that's the one. Did it? Oh, thank goodness. I was like, is it different data? Is it different? I wouldn't have known what that would have been. So that would have been a tough one to try to address. Okay, so now we're going to do a 2 samples test. So first we want to go back and select all of our cases. We're going to take off our social workers only. So go to Data, Select Cases, just hit All Cases, and OK. So everybody's going to be included. So now we're going to, so this was testing whether there was a difference between those with social workers and the overall mean. Now we'll test if there's a difference between the mean pre-score for those with social workers and those without those who didn't have a social worker. So between the 2 groups. So we are going to do a independent samples t-test for that. We're going to go to Analyze, Compare Means, Independent Samples t-test. Our test variable is again going to be treatment score pre. And our grouping variable is going to be our social worker dummy variable. We'll go to define groups. Group 1 is going to be 0. Group 2 will be 1. Continue.
That doesn't really matter. Does that?
I don't. Can you just run the test without doing that?
Or I'm just saying like group 1 being 0 versus group 2 being 1 doesn't really matter. No, which order? Yeah. And the reason that this is here is if you wanted to do it based on a continuous variable and you wanted to compare like those above and below the median,
then you could use the cut point function, since we're just doing a dummy variable, which is all you are going to be asked to do for this or anything else that gets more complicated with trying to use a continuous variable. And if I were doing it and wanted to test a continuous variable, I would make the dummy variable for the different groups that I was testing. I would not trust that define groups cut point function. Let me hit OK. Okay. So the first thing we look at is the Levene's test for equality of variances. And we see that we have a non-significant test there. And I just want to double check on my my cheat sheet handout the implications of that.
Oh. Maybe just want to like unselect.
Yeah, you have to go to select cases and to use all cases. Okay, if the results for the Levene's test are not significant, then you will read the results from equal variances not assumed. So we have a non-significant result on the Levene's test. So we're going to read the test of equal variances not assumed, which is the bottom line. And we see that we have a p-value of 0.07, which does it is above our 0.05 cutoff, so that we would consider that to be a non-significant result. I might add there that in many cases, especially with social science kinds of research, we do talk about marginal significance, and that is the 0.10 cutoff level. So you would be, if you set your significance level at 0.05, you would be correct to fail to reject your null hypothesis. But if you wanted to get a little bit more detailed about it, you could say that it is a marginally significant finding and is something along the lines of suggestive of the need for additional data and further testing.
So just to clarify for this specific example, if we're accepting the null hypothesis in this case, I'm not sure what like the null hypothesis is, like was or is happening.
Oh, yeah. So whenever you're doing a t-test, your null hypothesis is going to be no difference, or that the means are equal
between the things you're
comparing. And the alternative hypothesis is that there is a difference between the means. Mm-hmm. So if you're using mathematical notation, you'd want to put an equal sign for the null and a not equal sign with the line through it for the alternative for a two-sided test. Don't ever do one-sided tests. They're really just a way to try and cheat your statistics. So it's not good practice. Okay, any questions about independent samples t-test? Okay, so I don't know with this data if we can do paired samples t-test. I think, oh yeah, we can, because we have pre-score and post-score. So yeah. It depends on what your question is. So the one sample t-test is if your question is, how does a group or my sample compare to a known value that you want to set. The independent samples t-test is when your question is, how do these two groups compare against each other? And a paired samples t-test is when your question is, how did the same people's, or organization, or whatever your observations are, change at two different time points. I'm trying to think if it would ever be something other than time. I can't really think of.
The exact same sample or two samples from the same population? Exactly individual.
It's the exact same individuals for the paired samples. Yeah, so you need to have two different observations for the same individuals in order to be able to do that test. So we will go ahead to analyze, compare means, paired samples t-test this time. And this time we are going to compare attitude pre and attitude post to see if there was a significant difference in attitudes about treatment before and after treatment.
What will we ever achieve with attitude?
I'm not sure. We can try it and see what it does, but let's do the simple version first. Okay. So we have a highly significant result on this test. In that last column, our significance is 0, 0, 0. So the mean difference was a negative result. So attitude post mean was what attitude. So you can see in the first box there, their attitude pre, the mean was 2.39 and the attitude post was 3.61. So their attitude increased. We'd have to see exactly what that was measuring. And then we can see from looking at so we can look directly at our significance. We can also look at our 95% confidence interval and see that since both the numbers are negative, since it's not crossing 0, that's how we know that we're going to get that significant result. That definitely there was a negative difference between the two. Negative and negative makes positive. Let's see what happens if we do a second pair. Let's go to compare means, paired sample t-test. And for pair 2, we'll do our treatment score pre and treatment score post. It might just run the test twice. Yep, again, we get a highly significant result. We see that the mean treatment score before is actually almost double post. So our intervention seems to be having a pretty big impact. So we can be confident about that.
You could just run the same test all at the same time.
Yeah, I guess if you're
one.
And get them all in one table together so you can see. Yeah. I wasn't sure if it would do like a 2x2 and compare, but no, just runs the test twice. I mean, both of them together in the same. Yep. Okay, so any questions? One thing that that I'll just say that I was a little confused about in reading the homework is what exactly the treatment score pre and post is measuring. And if it's a measure of depressive symptoms and we had a huge increase, that seems problematic. But I'm pretty sure that that's not what, I mean, hopefully we did not like really mess people up with whatever intervention this was. So that, yeah. Yeah, so that was a question that I had when I read it and was anticipating, so that would be a question for the professor, because I'm not sure exactly what's being measured here. Yeah.
Does this say the national average pre-treatment score of depressive symptoms?
But like, you don't know if higher is better as far as.
Right, yeah. Because you would think that a score of depressive symptoms higher would be worse. Yeah, but yeah. Okay, any other questions? I think probably tables rather than graphs. You could maybe, just because like 2 data points you don't really gain much by looking at 2 data points on a graph. But maybe if you could do over time the treatment scores, because we have pre, mid, and post, and you could have 2 lines, one for the social worker clinicians and one for non-social workers. That might be a good visual. Do we want to try and see if we can make that? We'll go to graphs, chart builder, and we want a line graph with multiple things. So on our x-axis will be the y-axis would be our treatment scores. Oh, I guess I didn't like that. Yeah, I have not made charts in SPSS in quite some time. And as I recall, I remember in doing it that it was a lot of trial and error. Like if I try putting these here, if I try putting this here, it'll eventually make the graph that I want. So,
Yeah, can we also say in class that she prefer we use Excel?
yeah, so that would be probably an easier way of doing it, is that you could find the mean scores for each of the groups that you wanted to put on a chart, and then just make a table in Excel. And I would definitely find Excel graphs to be easier and more intuitive to use than the SPSS. Would that be helpful to do right now for an example, or? Yeah.
Yeah, you just make a table and I'll do it.
Yeah.
Thank you.
Mm-hmm.